In this video, we will take a look at another question where we need to draw a cam profile. So the question is, a cam is to give the following motion to a knife-edged follower. So the follower is a knife-edged follower. So the first thing is to raise the follower through 30 mm with uniform acceleration and deceleration during 120 degrees rotation of the cam. So the maximum height, that is h, is equal to 30 mm, that is given in the problem. Now this is h, and the rise of the follower is by uniform acceleration. Of course, for half of the during half of the beginning half of the rise it will be acceleration, and the second half of the rise will be deceleration. Both must be uniform during 120 degrees rotation of the cam. It means this is the angle of ascent, or when the cam rotates for an angle of 120 degrees, the follower must rise from the lowest to the highest position. So angle of ascent phi a is 120 degrees. Second, after it dwell for the next 30 degrees of cam rotation. So once it rises to the highest position, then there is a dwell of 30 degrees. So when the cam rotates for 120 degrees, the follower rises from the lowest to the highest position. And now when the cam rotates for another 30 degrees, the follower must remain at the highest position. Next, the follower must come down or descend with a simple harmonic motion during the next 90 degrees rotation of the cam. So this 90 degrees is the angle of descent. So phi d, here phi d is 90 degrees. This is delta 1, that is the dwell at the highest position. And next, for 90 degrees of rotation of the cam, after that the follower must come down, or it must fall, or it must descend. So the angle of descent is phi d, that is equal to 90 degrees. Next, dwell for the rest of the period. For the remaining rotation of the cam, that is total for one complete rotation of the cam, the angle is 360 degrees. So if you subtract this angle of ascent, then dwell at the top, then angle of descent, you will get the dwell at the lower position. So this is the dwell to 120 degrees that we have to calculate. So he is telling that dwell for the rest of the period, and he has given the minimum radius of the cam is 30 mm. So RC is equal to 30 mm. And the cam rotates counterclockwise at a uniform speed of 800 rpm, and n is 800 rpm. Draw the profile of the cam if the line of stroke of the follower passes through the axis of the cam. So now if the line of stroke of the follower is passing through the center of the cam, so that also is given. And one thing he has given is that the cam is rotating in counterclockwise direction. See, in the previous profile which we had drawn, if in the problem the rotation of the cam is not given, we take it by default as clockwise direction, rotation is clockwise. But if you have specifically specified that it is counterclockwise, then you have to consider it. Now if the cam rotates in clockwise direction, the profile must be drawn in opposite direction, that is in the counterclockwise direction. That's what we did in the last problem, where we had drawn a profile of the cam. But now, because he has in this problem, because it has been stated that the cam rotates in counterclockwise direction, so the profile must be drawn in clockwise direction. So that we will see while drawing the profile. Now we need to draw the displacement diagram first. So the displacement diagram, we have to observe that the rise is with uniform acceleration and descent is with simple harmonic motion. So we have to draw according to that. So again, now we will take the scale as let us say 1 centimeter is equal to 5 mm, and therefore 30 mm will be equal to 6 centimeters. So this scale we will take and draw the diagram. Okay. So now we will draw the displacement diagram, we will draw a height of 6 centimeters in the y direction. Okay, let us say this is 6 centimeters in the y direction, and then we will draw a horizontal line, that is the x-axis, and the line on the x-axis, it can be uh, of any length, but we have to divide it into equal parts, of course. So we just take an arbitrary length. Then now for the rise of the follower, again we will divide this displacement diagram into 6 equal parts. So for the ascent, we will divide the x-axis into 6 equal parts, let us say of 1 centimeter each. So it is a convenient division, you can take always 1 centimeters because there is no scaling in x-axis. So just divide it into 6 equal parts. Now draw the upper line also for an arbitrary length. Now we will number the lines starting from 0, 1, 2, 3, 4, 5 and 6. Now for constant acceleration displacement of the follower, select the middle line, that is the line numbered 3, and divide it into 6 equal parts, because we have divided into 6 the x-axis for ascent into 6 equal parts. So we divide this vertical line also into 6 equal parts. Now what you need to do is you just need to join the first division with the 0. So here this is the first division, let us say. From here join it to 0. Okay, and then the next, again join it to 0. The third division, it will be a diagonal. If you want, you can just mark it. This is number 1, then number 2, then number 3, this is number 4, and number 5. Of course the top one will be, and this is number 5, and this one will be number 6. Of course I won't mark that. So now we join the 4.4 to this top corner. Now the fifth point again to the top corner. Now once this is done, then you see the first line from the first point we have joined up to 0. So wherever this line cuts the first line, at this point you mark. That is your first point. Okay. Similarly, the second one will be the second line crossing this second. This will be the next point. Then 3. Then this is 4. And this is 5. Of course this will be 6. And this will be the beginning. So now, using a smooth curve, we will just join it. So this will be the displacement curve for the follower with uniform acceleration during ascent. So this is angle phi a, that is the angle of ascent, and that is equal to 120 degrees. So that is over. Now leave a little gap for the dwell. So this will be the dwell. And now for the descent also, after the dwell segment, you divide into 6 parts, 6 equal parts. This is for the descent of the follower. Okay, now number them again. Now see, this you have to start from 6, then this 7, 8, 9, 10, 11 and 12. So these are the numberings. So this segment is for the dwell 1, that is delta 1, that has been given as 30 degrees. And now this segment is for the descent 5d, and it is 90 degrees. Okay, now this descent is with simple harmonic motion. Now you have to draw a semicircle here, and then proceed accordingly. Okay, so now we will draw the semicircle. So now we draw a semicircle like this, and then we draw the horizontal line through its center. Now we divide it into 6 equal parts. So I draw the first part, then second part, third part is already there. Now we'll draw the fourth part. Now the fifth and sixth parts. So now we have divided this semicircle into 6 equal parts. Now we have to mark the numbers. See, now this is a descent. So descent means the numbering must start from the top, so that you should not forget. So 6 must start from here, then 7, 8, 9, 10, 11 and 12. Of course 12 is overlapping there, because see, at 6, where is the follower? It's at the top. So after the dwell also it must be at the top. So 6 must start from here, then 7, then 8. So it will come like that. So therefore you have to mark it from the top. 6, 7, 8, 9, 10 must come from the top. So in the previous problem we had the simple harmonic motion for ascent. There for the semicircle we marked from the bottom, 6, 7, 8, 9, 10, 11 and 12. So but for descent you have to mark from the top coming downwards. Okay, remember that. Now from this point 7, draw a line up to the line 7. Next from point 8 on the semicircle, draw a line up to 8. Then from 9 up to the 9th line, the 9th line. From the point 10 on the semicircle, draw up to the 10th line. Then from point 11, draw up to the 11th line. So now, those lines intersecting points you mark 1, 2, 3, 4 and 6. So now join all these points starting from here with a smooth curve. So this is the displacement curve for the descent of the follower. Okay, now if you want, you can just mark the numbers also. Normally we mark here. So because this is 1, here we will mark it in the blue color. Okay, this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, and this will be 6 dash, and then we have 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and of course this will be 12 dash here, and they will coincide. So these are the distances which you have to, this 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, and 4 to 4 dash, 5 dash, 6 dash. Similarly here 6 dash, 7 dash, 8 dash, 9 10 11 dash. These distances we have to transfer to the cam profile. So this is the displacement diagram for the given problem with constant acceleration, ascent of the follower, and simple harmonic descent of the follower. Of course the angles are 120 degrees for ascent, 30 degrees dwell at the top, and 90 degrees dwell at the bottom. So we will draw the profile in the next video. So we'll stop here today.